Hello and welcome to the fifth video in this tutorial series on how to use the MPT-Calculator. In this video we're going to be showing you how to export a .vtk file in order to be able to visualize eddy currents in an object of your choosing. So the object we're going to use for our demonstration is the one you see before us, the one that we've created in the previous video. So I hope you enjoy the rest of the video. Thanks for listening. Okay, so in the last video we just run a frequency sweep for the earring we'd created using a .go file. In this video we're going to show you how to create a singular point frequency sweep, so a frequency sweep containing only one point. The reason you might want to do this is so that we can export a Vtk file. This is not possible to do for the whole sweep as it's very memory intensive, so we're instead just going to choose a singular point to extract the eddy currents and see what they look like at that point. So the reason I've got the graphs up from the last frequency sweep is because we're trying to work out at which frequency we'd like to run this point at or simulate. So the point that's normally most interesting that I've found with experience is generally where the most activity is happening. So in this case, this looks to be about maybe 2 times 10 to the 5. And remember, working on a logarithmic scale here. So we're going to run a frequency sweep at 2 times 10 to the power of 5 and see what we come up with. Okay, so I'm back in the main folder now, and I've opened main.py and settings.py. So all we're going to do is just change the inputs so that we can run for a singular frequency. So what we need to do is we need to change the 2 values that correspond to a singular frequency. So we need to change single to true, and then we need to set the point at which, or the frequency at which, we would like to simulate. So as we've just said, we'd like to simulate the point at 2 times 10 to the 5. So writing that, we said 2e and then 5. We might need a plus 5 just there. Okay, so at this point we're pretty much ready to simulate, but we do also need to export the Vtk file or set it true. So what we need to do is go into additional outputs. There's more information on this in video 3, and then change this to say true. So at this point now we're going to run a simulation at the point 2 times 10 to the 5, and we're also going to export a Vtk file containing the eddy currents, or a visualization of what the eddy currents look like at that point. So additionally, we've got one final option that we haven't discussed yet, and that is refine Vtk. So this is an option that's offered by ngSolve, which lets you resolve the solution field before exporting it to a Vtk. This does, however, create a very large file, so we're just going to leave this false for the minute. And with this, we're ready to run our simulation. So we're going to open our terminal window that is currently located in this folder, in the main folder, and type the command python3 main.py. So clicking run, this is going to simulate using the old mesh that we've previously computed, and then simulate for a singular value. So we'll come back to you once the results are in. Okay, so that's finished running now. I've gone ahead and moved myself into the results folder. So as you can see, the folder name is slightly different now. This is due to us only having one point in the frequency sweep. Additionally, we have no graphs outputted. This is again due to there being only a singular point, so it'd be a far less interesting graph. We do still have the raw data, and then how the input files looked when it was simulated. However, this time we've also got an additional output, and this is located in the Vtk output. So if we click on Vtk output, we notice that there's this earring folder, and then also the folder at which, or the point at which, the frequency at which the Vtk file was produced. So in here we've got the earring.go, and then also the Vtk output. So what I'm going to do, I'm going to open this using paraview. You might have a different bit of software that you can view this in, but I'm used to using paraview. Okay, so paraview has opened, and I've loaded in the earring. I then click this little eye icon and clicked apply to be able to visualize what we've got here. So at the minute we're showing the entire domain. However, we're more interested in just the earring on its own. So in order to be able to get that, we have to use a threshold. There's a scalar field over the domain which has the object valued at 1 and everything else valued at 0. So we need to firstly click on the threshold filter. So there's a little shortcut to that here. It's the little Tetris looking one. Either that or you can find it in filters. So we'll click filter, click threshold, sorry, and then choose the scalar field to be the object. So we are interested in showing something that has a value of 1. So we're going to say that the minimum value is 0.5 and the maximum value is 1.5. So when we click apply, it will do its thing and then get rid of all of the outer domain. So then we can then zoom in to find our object. So zooming in, we find the object at the center of the domain. So with this, we can do a couple of things. Generally, we're going to let you play around with the stuff in paraview, but I will show how you do one thing, which is show some streamlines for the object. So to do that, we click on Streamline, and then we get to choose the vectors that we'd like to be chosen. So I think we're going to go with something a bit interesting and go with the E1 imaginary part. So this is the x directional vectors. We're then also going to choose it to be a point source and have a slightly larger sphere. So I think we're going to go for something about, not quite that big, something about 10, and we'll center it at, radius 5 rather than diameter. Other way around. So then we're going to increase that to, say, 10,000. And we'll leave everything else to be the same. So clicking apply, paraview is going to do its stream tracer and then produce some streamlines for us. Okay, so paraview has finished producing some streamlines for us. So what we're going to do, we're just going to go ahead and color these streamlines. We're going to use the x-axis or the x vectors and use the magnitude of those. And then I'm just going to click off the stream tracer because I'll end up messing it up somehow. And then we're left with something that looks a little bit funky. Maybe it's, I don't know, something sort of out of Doctor Strange, if you like. But what we're going to do is we're going to leave this video here. I hope you have fun messing around with some streamlines for your object, and I hope you've enjoyed the video. Thanks for listening.